this lesson, we're going to review the Correl formula. The Correl formula is used to find the coefficient correlation between two data sets. This is a statistical formula that's used within Microsoft Excel. The formula is explained as follows. There's basically arrays 1, arrays 2. So in the syntax, array 1 is the first data set that we want to analyze, and array 2 is the second data set that we want to analyze. So the formula is just equal to Correl, open parentheses, array 1, comma, array 2. Let's take a look at an example. In our example, a mathematics professor at a university has asked students to provide an honest poll of how many hours per week they each study. The mathematics professor wants to determine the correlation between study hours and test result percentages using this data. So is there a positive correlation between the amount of hours you study and the grades you get? We would say that there probably is. But let's take a look at the statistical analysis, because at a certain point there's probably a diminishing marginal return of the number of hours that you study and the grades that you get. So in our solution, we've got a breakdown of the students in column C, the hours that they study per week in column D, and their test result percentages in column E. So the students have provided their hours per week in the table below, and using the coefficient correlation function, we have determined that there's a 97% correlation between the hours studied and the test result percentages. And the way in which we can determine that is by applying the Correl formula within Excel. So if we open up cell E23, we can see that it's equals Correl, open parentheses. Then we select the first array, which is the study hours, in cells D29 through D36. And then we separate that with a comma. And then we put in the array for the second table. So we put in E29 through E36, which is the test percentages. When we press enter, we can see that the coefficient correlation between the two is 97%. So as you can see in the table, the number of hours that are part of someone's study habits result in increased test result percentages. So for instance, student 1 who studied 12 hours had a test result percentage of 52%, and the student who studied 30 hours achieved a grade of 92. If I were to modify this 92 to be 50%, let's take a look at what happens at the coefficient correlation. It actually drops it significantly. So that's how we know that the coefficient correlation is working properly. And if there is in fact a strong correlation between study hours and test result percentages, then that correlation will be closer to 100%. Let's take a look at one more example. In the second example, the manager of an antique shop has rare inventory on hand for items dating back to 1920. The manager wants to analyze the demand over time for the antiques. The manager wants to understand the correlation of time, i.e. years, to the demand for antiques using the data in the below table. So this is an example where you would expect that as antiques age and become more historical, their value may increase in terms of demand and pricing. So that's what the manager of the antique shop wants to know. So our solution is located below. We can use the coefficient correlation to determine whether there is a positive correlation or a strong correlation between the age of a particular antique and the demand that it has. So as we can see in cell E51, we performed the coefficient correlation calculation using equals Correl, and then we select the first array, which is D57 through D68. We separate that with a comma, and then we select the second data array, which is the demand. The first one was the year, and the second one is the demand. And the demand is in cells E57 through E68. When we press enter, we can see that the coefficient correlation is relatively strong at 72%, but it's not, 100% as it was, or pretty close to 100% as it was in our mathematics analysis for the students in the previous example. As we can see in the data table, we've got years 2007 through 2018, the demand of units by year, And as we can see, the demand for the antique has increased over time. In 2007, the demand for the antique was only 60 units, and the demand by 2018 for the unit is 120. If we were to increase this to 180, we would expect the coefficient correlation to increase from 72% and be a higher percentage, and it does. It becomes 78%. On the other hand, if demand for that old antique dropped in 2015 onward to, let's say, 50, we would expect the coefficient correlation to drop significantly, and it does. It actually becomes a negative value by 2018 because of the coefficient correlation. This is just another example of how the coefficient correlation can help draw parallels between two array tables that contain statistics, and it comes in handy if you want to represent that correlation into a specific percentage. Hey guys, thanks for watching this lesson. I hope you enjoyed it, and if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.